In the previous two videos related to the electrolysis, we have dealt with the basic concept of electrolysis. In the video 2, I have dealt with the electrolysis of the dilute solutions. Now, this is the third video, and I'm going to focus on the electrolysis of concentrated solutions. Now, the difference between the electrolysis of dilute electrolyte and a concentrated electrolyte is that when we were considering the dilute electrolytes, then we were again considering the rival ions, which one will be preferentially discharged. तो rival ion वो preferentially discharge होता है जिसकी electrochemical series में नीचे position होती है, जब हम dilute का देख रहे थे, right? तो अगर हम सिर्फ dilute देखेंगे तो सोडियम क्लोराइड की अगर हम इलेक्ट्रोलिसिस करेंगे तो एक हमारे पास Na ion है, cation, and the other cation is hydrogen ion. So when we were talking about the dilute electrolytes, the one which is at the bottom, that was easily, it was accepting the electrons, so it was selectively discharged, or it was preferentially discharged. And when we were dealing with the anions, so we had two anions there. We had the chloride anion and we had the hydroxide anion. Now, out of these two, again, the one which is lower in the position was preferentially discharged because the lower one can lose electron easily. That was the case of the dilute solutions. We were only considering their positions in the electrochemical series for cations and in the electrochemical series for an anion. But when we move on to the concentrated electrolyte, the scenario becomes little more complex. Now, when we are dealing with the concentrated electrolytes, तो सिर्फ हम position पे ही focus नहीं करते, बल्कि उनके बीच की ions which are present, उन पे भी focus करते हैं कि how many ions, the number of ions which are present in between those rival ions, the number of ions which are present in between the rival ions, right? So the rule for the discharge in the case of concentrated, that we have to look at the number of ions which are present between the rival ions. If the gap of two ions is there between the rival ions, if the gap of two ions is there between the two rival ions, then the one which is then the ion which is more concentrated is discharged. What do I mean by this? Now, if we have a look at these ions which are present in this electrolyte of sodium chloride, we say that it's a concentrated sodium chloride. So that means the sodium ion and the Cl ion, they are more concentrated. They are more concentrated. So the ions which are more concentrated, it's not mandatory that they will be discharged. Now, what we have to do is we have to look at the position and we have to also check the gap between them. How many ions are coming between them? Now, let's take the case of cation first. Now, when we talk about the cation, sodium and the chloride, even though the sodium ion, they are more concentrated, but there is a gap of how many ions in between? We have 1, 2, 3, 4, 5, 6, and 7. We have the gap of 7 ions there in between them. So the rule says that if there is a gap of 2 ions, then the more concentrated one will be discharged. So that means the concentrated sodium will not discharge in this case, because if there is not a gap of 2, then the dilute one, otherwise the vice versa. So that means over here, even though the sodium is concentrated, but there is a gap of 7 ions in between. So here the hydrogen ion will be preferentially discharged, right? Now let's look at the case of anion. The case of anion, we have the sodium, we have the chloride ion, which is more concentrated. The chloride ion is more concentrated, but there is a gap of 2 ions only. So according to the rule, if the gap of 2 ions is present, then the concentrated one will be discharged. So that means in this case, the chloride ion will be discharged. So once this decision is being made that out of these two rival ions, which one will be discharged, once it is decided, then it's simple to write down the equation for this. So let's write down the anodic equation first. So anodic equation we'll prefer to write down because we'll get to know okay, how many electrons are being lost. So chloride ion, one chloride ion will be losing one electron, but the chloride will be, it will be existing in the form of a chlorine molecule. So in order to make a chlorine molecule, two chloride ion, they should be losing two electrons. Now these two electrons will be accepted at the cathode by the hydrogen ion. How many hydrogen ion? Two hydrogen ion will be accepting two electrons. So they will be forming hydrogen molecule there. And we can very well see the observation in this particular diagram, which is being shown that because both are gases, the chlorine is also a gas and the hydrogen is also gas. So they have a setup here where both the gases are being collected. So chlorine is a gas which is greenish in color, and the hydrogen is a gas which is colorless. But we can see that both the gases are in the ratio of 1:1. So as we can see in the equation that we are getting 1 mole of chlorine and we are getting 1 mole of hydrogen. So that is the same observation which is shown in the diagram. We're getting the same volume of chlorine and hydrogen here. So whenever we are getting the same ratio of chlorine of the two gases, then we can expect that these are chlorine and hydrogen. If we get them in the ratio of 1:2, then we know it's oxygen and hydrogen, and the electrolysis of either dilute sulfuric acid or dilute sodium chloride or acidified water is taking place. Here we have the second case of copper sulfate, and we have a concentrated copper sulfate electrolyte. We have also dealt with the dilute copper 2 sulfate in the lesson 2 of this of electrolysis. Now in lesson 3, because we are dealing with all the concentrated electrolytes, so here we have a concentrated copper sulfate. Now the ions which will be present in this electrolyte are the copper ions and the H positive ion. And among the N ions, we have the sulfate and hydroxide ions. Now, because it's a concentrated electrolyte, so concentrated electrolyte means that I have got copper as a concentrated ion and the sulfate as a concentrated ion. Now, because there are rival ions, so both the ions will be moving, the cations will be moving toward the cathode. And these rival ions, they will be moving toward the anode, but only one will be discharged. And keeping that in mind that we have a concentrated electrolyte. So concentrated electrolyte doesn't mean that the concentrated ions will be discharged. As I told you in the previous slide, that we know that the concentrated ions are there, but then we have to look at the gap of the ions between them. Now here we have the copper. Let's put them on the, let's locate them on the electrochemical series. Here we have a copper, and here above that we have hydrogen. So there is no ion in between. So the more concentrated will be discharged. That means in this case, at the cathode, the copper ions will be discharged, right? Now, considering the anions, among the anions, we have the hydroxide and we have the sulfate, right? The sulfate are the more concentrated. Now, let's look at the distance between them. So we have a gap of 1, 2, 3, and 4. 4 ions in between. And the rule says that if you have 2 ions in between, then the concentrated is discharged. But here we have 4 ion gap in between the 2 ions, right? So definitely the concentrated will not be discharged. It will be the dilute one will be discharged. That means the hydroxide will be discharged. So here the copper ion will be discharged, and in this scenario, the OH ion will be discharged. Once this has been decided, it's very easy for us to write down the cathodic and the anodic equation. So our anodic equation, which we always write down first, anodic equation, the OH ions, so always the 4 OH ions, they will be discharged in order to give 2 water, and they will be giving you oxygen, plus they will be losing 4 electrons, right? So this is an aqueous solution. Here we are getting water in the liquid form and oxygen in the gaseous form. The cathodic equation for this is going to be, because the copper ions are being discharged at the cathode, right? So they are in the aqueous state symbol, they will be accepting. So how many? They have to accept 4 electrons. So in order to accept 4 electrons, How many copper ions will be taking 4? It's the 2 copper ions will be taking 4 and will be getting 2 copper atom deposit at the cathode. We can very well see that the copper being deposited in the reddish brown color over the cathode here, and we can see the gas. We can see that the electrolyte is being pushed down and we have an empty space here, which is showing that we have an oxygen. Now, whenever a gas is being collected, we always we always identify it by performing its identification test. So we will bring a relight, we will bring a glowing splinter which will relight back again. That's going to prove that this is an oxygen gas. So the observation for this particular electrolysis are that because the copper ions are being deposited and the copper ions are coming from the solution, so the solution is going to fade off, right? The color. So the observation are, number one, the color of the solution will fade off. Number two, there will be pink deposits seen around the cathode. And number three, there will be the bubbles liberated at the anode. When we test these bubbles or the gas collected, that's going to relight the glowing splinter. So these are going to be the 3 observations. If this kind of a question comes in an ATP, so these are the observations the examiner can ask you about. Now, this slide is actually whatever I verbally explained you. This is the gist of all that. So whenever we do the electrolysis of concentrated copper sulfate, right, using the carbon electrode. So this is what happens here. Now we will be having the copper ions, the sulfate ions, the hydrogen ion, the OH ions, right? Now out of these two, the copper and hydrogen will be migrating towards the cathode and sulfate and OH will be migrating towards anode, but preferential discharge will be of the copper ions, right? Because there is no gap between them and the more concentrated one is discharged. Now, when we talk about the OH and the sulfate, with the rival ions and the OH, there is a gap of around 4 ions in between the OH and sulfate. So the OH ions, they will be losing 4 electrons to form 2 water. They will be forming 2 water and they'll be forming oxygen, right? They will be losing 4 electrons. Now, the observations, as I already told you, you'll be seeing the pink deposits, right? Pink or the reddish brown deposits, they will be seen around the cathode. Remember, at the cathode, either the metal is deposited because the cations are the metal ions, or the hydrogen ion. Either the metal will be seen depositing at the cathode or the hydrogen gas will be liberated. So at the cathode, we need to be very specific, either the metal or hydrogen gas. And at the anode, mostly the gases like oxygen, chlorine, bromine, these are the gases which are liberated at the anode.